Hello, I'm Percy the Bandicoot. We're ready for another part. Here, we'll talk about real transformer. On the other hand, the ideal transformer model neglects the following basic linear aspects of real transformers. Core losses, or magnetizing current losses, consisting of hysteresis and eddy current. Unlike the ideal model, the windings in a real transformer have non-zero resistances and inductances associated with Joule losses and leakage flux that escapes from the core and passes through one winding only, resulting in primary and secondary reactive impedance. Also similar to an inductor, parasitic capacitance and self-resonance phenomenon due to the electric field distribution. Three kinds of parasitic capacitance are usually considered, and the closed-loop equations are provided: capacitance between adjacent turns in any one layer, adjacent layer, and the core, and the layers adjacent to the core. In this diagram, inside the magnetic core, there is a leakage flux which, generated by the primary winding, links all the turns of every winding, including itself. Leaky transformers may be used to supply loads that exhibit negative resistance, such as electric arcs, mercury and sodium vapor lamps and neon signs, or for safely handling loads that become periodically short-circuited, such as electric arc welders. Air gaps are also used to keep a transformer from saturating, especially audio frequency transformers in circuits that have a DC component flowing in the windings. A saturable reactor exploits saturation of the core to control alternating current. We can show that if the percent impedance and associated winding leakage reactance to resistance X by R ratio of two transformers were the same, the transformers would share the load power in proportion to their respective ratings. In accordance with the electromotive force, if the flux in the core is purely sinusoidal, the relationship for either winding between its RMS voltage is given by 2 pi times F, the supply frequency, times N, the number of turns, times A, core cross-sectional area in square meter, times B peak, the peak magnetic flux density in Tesla, divided by square root 2. We get 4.44 times frequency, number of turns, area, and peak magnetic flux density. So this section we have called real transformer. Like, comment, and subscribe now.